Hey guys, we're going to go over another problem dealing with chords and their bisectors. So in this problem it says, in the accompanying diagram of circle O, diameter AB is perpendicular to chord CD at E, so we can automatically fill that out as two congruent segments. CD is 8, so this is going to be 4, this is going to be 4, and EB is 2. It's going to be 2. What is the length of the diameter of circle O? So we're trying to figure out the length of AB. So I'll just make a note of that here. It's going to be our goal. Alright then, so one of the differences between this problem and the other problems that I've covered is that we're normally given this piece. So that when, or this piece, right, the radius, so that when we do construct our right triangle, we have two sides, and we just need to just quickly use the Pythagorean theorem and figure out the third side, and we'll get our answer. But that's not the case this time. We actually don't have the radius at all, or even this side. So let's see. Let me just pull this out and draw a right triangle here. So this is E, this is going to be O, and this is C. So all I know is EC, which is 4. I don't know OE, but I know OE is part of this radius, OB. And I know a portion of it is 2. So how would I normally solve for this part if I already knew the radius? Well, let's say the radius was 5, right? If OB was 5 and I did 5 minus 2, I would have gotten 3, right? So because I don't know the radius, I can let the radius be, just some variable, let's say r. So if the radius is r, let me write that, radius is just r, then to find OE, I can just write r minus 2. I can write it as an expression. So I'm going to write r minus 2. And then OC is just my regular radius, so that'll be r. So now I have variables in this right triangle. And again, if I have a right triangle and I'm looking for missing sides, I can use the Pythagorean theorem. So that's what I'm going to be doing here. So we know Pythagorean theorem is a squared plus b squared equals c squared. My a is going to be r minus 2 squared plus my b, which is going to be 4 squared, equals my c, which is going to be r squared. Okay, so here we have a binomial being squared, so let me just write that out in its expanded form. 4 squared is 16 equals r squared. So we're going to end up foiling here, or distributing, or using the box method, whichever you're comfortable with. And then we'll be continuing on with how we would normally solve an equation. So r times r is r squared, negative 2 times r minus 2r, this times this, minus 2r, and then this times that. It's going to be plus 4 plus 16 equals r squared. Okay, so I just distributed everything. And then I'm going to combine like terms. So that's going to give me r squared minus 4r plus 4. Actually, no, I can just combine these. 4 plus 16 is 20, so plus 20 equals r squared. I'm going to subtract r squared from both sides. Minus r squared, and I see that they both cancel out to 0. So now I have negative 4r plus 20 equals 0. I'm going to add 4r to both sides, and then I get 20 equals 4r. What number times 4 gives us 20? Well, that's 5. So that means my radius equals 5. And that means my diameter, which is AB, is going to be 10. So what is the length of diameter in circle O? Well, AB, already right here, AB equals 10. Alright, so that's pretty much it in this case. We're no longer just staying in the comfort of having two sets of numbers. We're now transcending to like more algebraic setups with more variables and quadratic expressions and whatnot. But that's pretty much the basic idea. So if you have any questions or comments, leave them in the comment section below. Let me know if you want another question to be reviewed, and I'll happily cover it. And that's pretty much it. Alright guys, take care. Bye.